Welcome.
I do speak 3 languages.
See. To
Good dog.
well, a hopefully learningful, meaningful, but also potentially fun panel discussion on why we think, or what these guys think, my opinion doesn't matter here, is important to learn for your career and why we think that might be something worth considering. I'm being joined by Mr. Andrew Prusky, DBA from the Cold, Anthony E. Nocentino, or Centino.
Papa Luigi.
Si, it's a me. Argenis Fernandez, DB Argenis, and me, Ben Weissman. And with that, these were our slides. This is just basically a word cloud of what we're going to talk about. Let's maybe start for the people in the room. We could do show of hands, but we can't see you, so.
I can see them. I have a nice hat on, so I'm blocking out the light.
We're still going to start with a quick.
Okay.
Anthony.
I was offering my services to count.
And like, briefly, what is Kubernetes?
Kubernetes.
Take the mic a bit closer.
Like this? Like this?
Yes.
Yes?
Yes.
Okay. What is Kubernetes?
Yes.
It's a container orchestrator. And jokingly, I like to say Kubernetes has one job, to start containers on nodes in a cluster. And so you're like, what's nodes in a cluster? Basically a collection of compute resources in a cloud or a data center. So if you have a container-based application and you want to deploy it, Kubernetes is the predominant way now to deploy container-based applications in a cloud or data center.
Okay, this is going to take a while. Thank you for explaining us everything by skipping the bait. Andrew, maybe you're of better help here. What's a container?
So let's break it down. You talked about Kubernetes is used to deploy containers, but didn't go into what containers are. If you go on the Docker website, you'll see things like a container is an object that contains all the necessary binaries and libraries required by a piece of software to run in the same manner, no matter where it's deployed. But practically, we'll think of a container as an object that's lightweight, has a specific job to do, say running an application for us database folks, something like SQL Server, and it's quick and easy to deploy, easy to customize, and easy to share.
So basically, Argenis, I guess, same page, you and me both. Containers are fancy VMs?
Oh, well, that's a discussion right there. So containers are so not VMs. And the reason is that there is no really a virtualization layer required to run a container per se. There doesn't have to be a hypervisor running underneath the hood for you to kick off a process that is actually going to execute your container. So they are definitely not the same thing. They can be seen more as isolated, discrete applications, rather than full-blown, guest operating systems with a bunch of applications. Now, with that said, and let me just take a second here to highlight this fact, it probably is the case that you are actually going to be running your container process, right? So your memory space of your container is going to be under their management of a hypervisor. And that's different than running just on bare metal itself, right? Because you could totally run a container on bare metal.
Okay, so I could install Kubernetes, and I could take bare metal and just make this,
yes.
Multiple bare metal machines, obviously, and make this a Kubernetes cluster.
Right, so I don't know why people think that Kubernetes is the super complex thing. It may get super complex if you look at it the wrong way, but you can literally run Kubernetes right now on your laptops.
Because config maps.
Ingress. Just saying.
Storage.
Networking.
By the way, we want to keep this as interactive as we can, so whenever you feel like, hey, there's a question that you either want them to elaborate more on or just something that you always wanted to ask about Kubernetes, this is the time. So just interrupt us anytime. Also, anyone watching online, our moderators will make sure to interrupt us on your behalf.
And Ben, you're responsible for getting the mic down into the audience so we can hear the questions.
Yep. If you have any questions, just raise your hand. Right?
I will.
Oh, we have a question. We already have a question.
Okay, so the question is, what's the decision-making? When would I choose a Kubernetes or containers over VM? Maybe a question, can I just run any software in a container? Or might that even be part of that decision-making process already?
I'm going to take that one. So
okay.
You looked like you were ready for that.
So there's a few things that you have to consider when running an application in a container, right? typically which platform you're targeting, right? So Kubernetes can actually run multiple operating systems for the nodes in your cluster, right? So a cluster is comprised of nodes, and your operating system, they're going to be running a particular flavor of an operating system. So that's an environment that Kubernetes is going to be able to run on. It could be Linux, or it could be Windows, right? So you can have Windows containers, or you can have Linux-based containers. And so there's going to be fundamentally a difference between what you're going to be able to run in either of those, right? And so if you think about an application that was designed and developed for Linux, you're more than likely going to be wanting to create Linux-based containers for that one application. And there are also considerations around GUIs, for example. Does it make sense to actually run a GUI in a memory space of a container? You may not want to do that, right? Although you can actually run a full-blown operating system in a container, including a GUI, and then serve that GUI up via a port, right, on their own network, and then access the GUI that way. So for example, a really great trick of debugging containers is by running the actual application on say an Ubuntu-based container, and then VNC into that container image. That's a valid way of debugging it. Yep.
So, to go maybe a little bit level deeper, no offense, is
offense is taken.
It's totally, sorry, Argenis, we're friends.
Not anymore.
Yeah. Did you just unfollow me on Twitter?
Yes.
So one of the things I talk about when you're building applications, it's not what's the decision between do I choose this or do I choose that, but the value that a container provides for an application builder. And so the primary problem that a container is going to solve when you're building and deploying an application is how many of you have a web server or an application server dedicated to an application because version XYZ of some DLL conflicts with version LMNOP of some other DLL, and you have an isolated machine just for that, right? And so what a container brings to the party is it'll take all of that, wrap that up in a memory space, as Argenis described, and that is then restricted to that particular container. So then I can deploy binary XYZ with that DLL and binary LMNOP with that DLL on the same piece of hardware, right? And that's the real benefit that a container brings to the party versus having to have dedicated virtual machines that I have to independently service and patch and compute and all that fun stuff. And so that's really, if you are in that situation, I think that's the decision process versus VMs versus containers. And of course, as Argenis indicated, you can certainly run containers on VMs because in my experience, especially working with stateful applications, being able to move a virtual machine between node A and node B in a cluster is still an awesome piece of technology that you won't get out of straight Kubernetes because a process has to terminate on one node and start on another node. There's no concept of process migration. And so almost 99% of the clusters I've seen are built on VMs, and I really reap the benefits of that with stateful systems because I can move a workload in between hardware devices without taking a downtime.
And now if I can add into what you were saying, if you really think about the value that a hypervisor provides, it's not just being able to move workloads seamlessly across nodes without bringing them down, but you also get the benefits of avoiding CPU sideline vulnerabilities, right? So like Spectre and Meltdown kind of vulnerabilities, those are definitely mitigated by the fact that you're clearing the CPU cache in the registers for the next process that's going to run on the CPU with VM entry, VM exit instructions at the lowest level. So that's an additional value add that you get from running on hypervisors. So if in the end, if you have code that you don't really trust, that you're going to be running in your containers, you definitely want to run on top of a hypervisor because that's going to offer you the higher level of security.
Yeah, there's no assumption of security boundaries between containers, and the only way to guarantee a security boundary is to what Argenis described.
Although, correct me if I'm wrong, you've elaborated very much on the question why I would pick running my containers or my Kubernetes in VMs compared to running it on bare metal. Did it answer your question why I would pick running an application in a container rather than running an application in a VM?
Well, I was going to add to that. I'd also look at resource consumption and resource usage. Would you need an entire VM for an app that's just going to sit there and trundle away and have all that manageability about having to manage that VM, patch that VM, sort out high availability for that VM? If you can get away with it just running in a container on a Kubernetes cluster, you've scaled that down. You don't have to deal with managing the OS of that VM. You have high availability built into Kubernetes as well. If a node goes down, that app will fail over to a new node. So you need to really look. It all depends on the. It all depends on the application that you're deploying. If the application you're deploying is stateless, you're going to have and say reasonably low in resource consumption, then you can have a look at Kubernetes, whereas just building an entire VM for it and deploying on a VM.
And I think I really want you guys to think about what's the unit of mobility of a workload. Right, if you leverage the VM concept, you're moving entire VMs. There's no way of partitioning that VM into just moving sections of it, right? When you're working with containers, that container is a small, hopefully a small, unit of work.
You're talking to a chap who's built 20 gig images here, so.
But you get what I'm saying, right? A VM can be very fat, right? And I mean that.
Did you just call my VM fat?
Yes, big boned.
Shame.
Not cool.
I'm not sorry.
Okay, but then again, I mean, you've been to the keynote this morning, Argenis, right?
Yes,
and you've been talking about all these different offerings that I get in the cloud.
Yep.
Not just Azure, any cloud-based.
Yep.
If we talk about, hey, this is microservices, hey, I want to have this specific setting different on this application rather than that, and I basically have tons of instances of the same application. Why would I pick running my own containers over just running a managed cloud service?
I think.
Can somebody hold
Go ahead, Andrew, go
I
ahead.
think he's about to bite me, so.
Yeah.
So we're talking about whether or not I should go for a managed Kubernetes provider in the cloud, whereas running my own, either just containers
we're talking about,
or.
why would I even consider deploying my own web service container instead of just going, hey, Azure, hit the create button that Steve showed us in the keynote, and just deploy all that in Azure, because I need 5 different web servers, all using the same application stack, but one uses this .NET framework, one uses that. We were talking about that isolation level. Why would I even bother about going through all these configuration isolation myself instead of just saying, hey, Microsoft, do this for me?
All right, so
please.
we're breaking it down now as why do I want to manage all of that locally, whereas I can shove it in the cloud and manage it.
So you're saying locally, so Kubernetes is on-prem only?
No, I'm not saying that. Okay, so no.
I'm putting words in your mouth.
Yeah, a little bit there, little bit. Why would I manage, say, if I was deploying Kubernetes containers and pods to a Kubernetes on-premises compared to deploying something like Azure Kubernetes Service? There are other cloud offerings available.
Thank you.
But why would I use a managed Kubernetes service over on-premises? The best way is that the best way to describe it is Kubernetes can get complicated. If you really want to dive into Kubernetes, building your own Kubernetes cluster locally and diving into the control plane is a fantastic way to learn. But trust me, for someone who's gone through the pain, if you...
We're here for you, Andrew.
Yeah.
It's an open space.
If you're just getting into Kubernetes, deploying a cluster with one line of code, it was a AZAKS, create cluster, nodes 2, thanks very much, and building out there and deploying there is a really quick way of getting a Kubernetes cluster up and deploying an app in, and your app will be up in what? It takes like 10 minutes to deploy the cluster. At most now, it's gone a lot quicker.
Definitely.
And then you can deploy your app, and your app is up and running. Building your own cluster requires deploying your own nodes, configuring your own nodes, installing via some method, usually kubadmin, then configuring out whether or not you want high availability for your control plane. Do you want to separate your etcd cluster into separate machines out there to take that away from it? So there's a whole bunch of other stuff you need to take into consideration. Now, if you have the skills to do that, absolutely there are benefits to doing that. But cloud offerings, and the same with any cloud offering, takes the pain of that management away. So it's when you're looking at whether you want to deploy on-premises or in the cloud, those are the benefits that you get. On-premises, you manage everything yourself. It's down to you, whereas deploying in the cloud, Microsoft, Google, AWS takes some of that pain away for you. And you just have to worry about deploying your applications and managing your nodes and upgrading your nodes.
Yeah, and I think that one of the biggest things to highlight there is the fact that you have that elasticity in the cloud that you don't get from having a cluster
Absolutely,
on-prem, right?
Yeah, I want 4 more nodes, thanks.
Right.
So there's one little secret about Kubernetes that...
Closer to the mouth.
Thank you. I failed in my rapper career. Anywho, there's one dirty secret that Kubernetes folks don't talk about. The cluster part's actually easy, I think. When you have to deal with the other parts of your infrastructure, that's where it gets hard. So what do you get in the cloud? You get a solution from the networking to the cluster, to the storage, and all the ancillary services around that for backup and support and all that fun stuff. And so, excuse me. When you're on-prem, you have to go find load balancers that are going to integrate with their cluster. You have to go find a storage solution that has dynamic provisioners so that you can allocate storage to your applications. In the cloud, that just works. Automation is, all the tooling is smooth across, and you can just consume that as a service. And that's pretty much the same concept behind any PaaS service. Like, why would you go with SQL DB for something? Well, I just mash a button and I get what I need. I get access to it, I get backups, I get storage, all that fun stuff. And so that's another consideration as well, because there was a time in my career where I was an expert at using load balancers on-prem, not so much anymore.
To point out, do you remember was it about a year ago? We deployed EKS in my company. We had an issue, we had a networking issue with the communication between the nodes, and we couldn't figure out, the solution was, well, we're in EKS, but let's not fix that cluster, let's spin up another cluster, point everything to the new cluster, bring everything up, blow the old cluster away. If that was an on-premises cluster, we'd have been sitting there fixing. I mean, we eventually managed to get the, I can't remember what the fix was, and I really wish I could. But that's what the cloud brings. As Argenis was saying, the elasticity. Blow that cluster away, spin up a new one, boom, you're up and running.
On the other hand, and I want to play devil's advocate here against myself, I guess, the fact that you're running Kubernetes on-prem, running with very specific, say, storage solutions, for example, which you're very familiar with, Anthony, and I am as well.
Other storage solutions are available.
You may be capable of doing things that you're not going to be able to easily replicate in the cloud.
True.
Okay, so that is always something to consider. There may be some very specific use cases where you may want to leverage on-premises solutions, for sure.
One thing that I would like to add, because I think that is super important, especially in this hybrid world where you may have infrastructure in multiple clouds and on-prem. One of the key benefits of Kubernetes for me is the complete abstraction of anything hardware related. So if we look at these fancy modern services, yay, Azure Arc, we're like, yeah, I'm going to run my managed instance, some in AWS, some in GKE, some on-prem, some here, some on the edge, some there. I can basically use the same code file to deploy everything, and Kubernetes will, those might be completely, entirely different clusters, and this is kind of where I see the beauty, whereas...
a caveat to that is the same Kubernetes version clusters.
Yeah.
Just that we know your pain, mate. We know the pain.
With different Kubernetes versions.
That's the banana peel, right? You always can find one of those on the road.
Yeah, absolutely.
Thanks for working that in. Goes with the motif, banana peel.
You're welcome.
Yep.
So, I recently heard a term, maybe you can, sorry, is there a question?
Is that a question? Go ahead.
Ben, you have to get down there, mate.
I'm running. That's what I do.
What do you think about bringing the orchestration and Kubernetes part in the development process, and how that aids the development besides containerizing?
That is an excellent question. So, what's your thoughts on using Kubernetes or container orchestration in general? Bring that into your development process. How does this support developers in their development process? How does it make because so far, to our question, why should people in this room start learning Kubernetes?
Very infrastructure focused
so far. The answer is basically because it's very hard to learn. That's my takeaway from
So I have a story about this. This is a while ago. We replaced my QA team in a couple of companies ago now, replaced all their SQL instances with containers. So instead of, they used to refresh their QA machines, they blew away the VM, they installed everything with Chocolatey, and then they installed SQL Server. And they did this a couple of times, well, I'd say a couple of times a quarter. And it'd take about, I'd say, 60 to 80 minutes. And we're just installing the database engine here, just sitting there and then restoring databases. We blew all that away and replaced it with containers. And we were using something called Windocs at the time because we didn't have Windows containers going down to 2012, and that's what we were on. So we replaced everything. We had it in containers, but we were on one host. So everything was working fine until I came in one day, and that host was down, and all the QA processes couldn't work because none of the databases were online. If I could do it now and rebuild, I would have absolutely built everything on Kubernetes. That host goes down, don't care. Everything would have failed over. I'd have walked in the morning and gone, oh, a host is down. Fix the host. No bother. QA continue on with their work going, not a problem. Development and QA processes running SQL Server in particular are absolutely primed to run on Kubernetes. All they need is a SQL instance. They don't care where it is. They just want it up. They can sit there. They can hit that. Go for it. Absolutely go for it. Yeah.
So you're saying SQL Server. SQL Server is a stateful application.
Yeah.
I've heard earlier we're using these containers with stateless, microservices. How does that go together?
Take it, buddy.
Oh, the storage expert here can go for that
We
one.
just said stateless though, not stateful.
Oh,
I do want to add to that actually the last point, and maybe that'll kind of cover what you're covering, Ben, or covering what you want to get at, Ben. This is, for a developer, this is the power of Kubernetes. I sit at my workstation, I'm writing code, I commit my code, right? That code commits, I can have a build pipeline, pop out a container into a container registry for me automatically. And then I can have the cluster monitoring that container registry, or vice versa, have it automatically push and update that image in the cluster and roll out my application. And so if you think of about that from a workflow standpoint, that could be a fully automated process. And when I talk to folks about why Kubernetes, the most expensive thing in your data center is you, right? And your developers building code. And so the number one reason Kubernetes exists is to get code out of developers' brains and into production as fast as possible. Full stop. All this cool technology has nothing to do with anything else other than getting code from here into there, right? And into production, because that's going to add new value to your business, new features to your applications, all of those different things. And so I commit code, and that pipeline kicks off. And if I have good testing, that can roll right out into production automatically, right? And that's, I think, the value for Kubernetes and the value to developers, right? Because before, what was written scripts and shell scripts and pulls and gits and images and install files and MSIs, a bazillion different ways to roll out code. And we have this thing that I can just push and go, right?
Yep. So I used to work in the SQL Server engineering team, and even the way that that's the testing and validation is done in containers has significantly improved the way that testing is done at Microsoft. So that is, even at Microsoft at that scale, developing products of enterprise caliber like SQL Server, containers and Kubernetes have been a magnificent choice for development.
Follow-up
We
question,
have
Ben?
is that a follow-up to that question? I'm running.
Go. You want to use my cart? Oh, there's a cart.
Time? We got
Okay.
20 minutes?
Yeah.
But should it be in the developer's responsibility to take care of the
I feel a wireless mic would be helpful.
Yeah.
Okay, so who's in charge of Kubernetes? So we see the benefits for the developer in a Kubernetes process. Who's in charge of the Kubernetes cluster? Is that the developer himself? Is it basically bring your own cluster from a developer point of view? Or should the developer rely on, hey, there's a Kubernetes team, just like there's a DBA team making sure SQL Server is running, there's a Kubernetes team making sure Kubernetes is running, and they can focus on whatever they need to do from a coding perspective, not from an infrastructure perspective.
Yes.
Yeah, that's a massive it depends, man.
Yeah, it is.
Yeah.
So, I mean,
Any of you up there like consultants or anything by chance?
Not anymore. Not anymore.
Yeah, it seems to be still.
but I mean, you may be running locally, right? If you're running just on your local environment, obviously you're responsible for your own stuff. No one cares if your laptop breaks; it's on you. And your IT department can help you with that. But typically, there's an SRE team, so a site reliability engineering team, or somebody who's dedicated
Platform
to
team,
the
yeah.
DevOps function within your enterprise. That's going to help you handle that for you. But it really depends. It really depends.
Going a little bit, my company, we're still with sysadmins. I'm a DBA. They look after, the sysadmins are the ones who look after the Kubernetes clusters. We have a release team as well who are quite heavily involved. But yeah, it really does depend.
Yeah.
Do you want to?
That question was answered actually.
Okay, cool. So to add to that, one of the things, the analogy I like to make, and to bring it back to like VMware and things like that, you still have platform engineers that build things, right? And that analogy can still persist inside a Kubernetes space. You have platform engineers that are experts at running the applications versus building the applications.
Yeah.
And a lot of that goes in how an organization is constructed and the people and the skill sets in New York. So that's really, I think, why it depends, is what the company is doing, who works at the company, and who's good at what, basically.
It's
inside of a company.
the old paradigm of infrastructure and code, right? It's the same idea, same principle. And data.
Or a developer has an AWS account and rolls an app in and just migrates over to it. We've seen all that too.
Oh, yeah, of course.
Yeah, so I wasn't sure if my question on stateful versus stateless application was fully answered, and it seems like the audience agrees with my perception.
Oh, did we not answer? Should we be running? Was it basically should we be running stateful applications in Kubernetes?
I would say so. That
Is that the question?
basically
Should
what
we
it
run
comes down
stateful
to.
applications in Kubernetes?
Or
Please answer,
SQL
because
bits,
otherwise I may have to
right?
throw away these books because.
No, seriously, I mean, I think that the best example that I can bring up specifically for that is, think about a database
Right.
server that where you need to undo a patch. Like, how do you undo a patch or a service pack on a database server? On a big
You
beefy
can roll
database
back
server?
at CU. You can roll back a CU.
You can roll back a CU.
Yeah,
I mean-
but how long does that take? On
Oh yeah, I got an RDP, I got to click on the thingy, and I got to go to the control panel, and I got to go to add remove,
Have
and then I
you
got to wait
heard
for the
of
screen to
CSC?
refresh.
Exactly right. That's exactly right.
Right.
So how long does that take on a container?
Oh, I change a character in a tag. One of the things when I teach Kubernetes to folks, especially about stateful applications, and you go on the internet and people have lots of opinions about running stateful applications in Kubernetes. I said this in my last session. Nobody cares if SQL Server's online, right? What they care about is getting access to the data. That data is going to live in your data center
Have you
as
even talked
Wonder
to
where you were
DBA
going with
lately?
that.
what? What's that?
When you said nobody
Any
cares if
DBAs
SQL
in the
Server's
room that would
online.
agree to the statement they don't care if SQL Server is online.
Yeah, no, they're literally both of us would look.
Dramatic pause. You're messing up my
Read the
flow.
room, dude. Read the room.
You know, I had a flow and now it's gone. Anyway, so nobody cares if SQL Server's
Mamma
online because
mia.
what they care about is getting to the data, right? And the data lives on a storage device in a data center. And that's really all a server did. You have a process, or like a VM or a Windows box, whatever. You have a process that's running that knows how to read that data, right? That's all a container brings to the party. You have a process running on a node inside of a container that knows how to read that data, right? And that's it. And folks that they're like, oh, I shouldn't run stateful applications inside of Kubernetes. Well, you're just running a process. The data lives somewhere, and not necessarily physically on the cluster. It could be in any storage subsystem, right? It doesn't have to be node local or anything like that. And you'll see test labs like that. But I feel strongly about that because I think that it provides a lot of value, right? Because now I have a cluster of n number of nodes that have the ability to run a container for me to get access to the data that I really care about, right?
Yeah, I completely agree. What Kubernetes and containers have done is basically separate out the compute from the data. So we no longer have, we like our SQL Server VMs, we nurture them, we look after them, we stroke them, we sing them lullabies to make sure they're good. With Kubernetes, we go,
I actually
bang,
just pray in the corner
gone,
and
you're
make sure
gone,
they
we
stay
can't bring a new
online.
one in. Yeah, we don't care about the compute. We can bring in computing anyway, it's all about the data. We don't care where the data is being accessed from, as long as that data
But I guess
can
some
be
people can
accessed.
see that as a sensitive thing because they can think, that because of the innate ephemerality of a container, that the database server should not go on it. And things couldn't be any more different than that, right? Realistically speaking, a container can be running for a really long time. And if you're helped or aided by a hypervisor underneath the hood,
Yes.
you're really looking at high availability for that container itself. So you're providing that HA that the database server needs. There's a question online, I believe.
Oh, yep.
Does the process come with issues? Does it need to be tuned to perform in a certain way, or does it just work great out of the box?
So is that
When we say process-
Are we talking about the SQL Server deployment process specifically, or
I think
Or
it's
SQL Server performance, like system management, like that kind of stuff.
so does that work out of the box, or do I need to do something to make that work like all nice and smooth?
I get this question when I talk about Kubernetes a lot, and it's just another platform to deploy SQL Server to. You still need to do all the same management things that you do. It's just somewhere else that you can deploy SQL Server. So you need to be taking backups. You need to be making sure your log backups are running, things like that. You need to be doing your same performance tuning. You can't just deploy into Kubernetes and go, hey, everything works now. I don't need to touch this. You still
you
need to
even
do
heard
the
about
same
Arc?
management things. It brings certain things for you, like inbuilt high availability, but again, there are caveats to that,
Yeah.
which I was going to mention just now. Like someone asked, stateful applications in Kubernetes, you can absolutely run them. You need to tune your deployments
Yes.
specifically. You will run into issues where, say, a node goes down. The default timeout for an application in Kubernetes to fail over is 5 minutes. If your SLA can take 5 minutes, you need to go and tune that. You'll have issues I've seen in Azure. It may be fixed now, so massive caveat to that, where it just wouldn't fail over. So we had to use a different
Yes.
storage solution that would take the volumes across and things like that. So there are little caveats there. But you can absolutely run stateful sets in Kubernetes. You just need to And I can't stress it enough. Test, 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 test. And try and, what's the first thing you do when you get a new application running in a new system?
Roll it out.
Try and kill it.
That's what you do, yeah.
So Kubernetes is not a magic turbo button, all right? What it does is provide all that value that Andrew was describing. But if your code or your processes suck, they're going to continue to suck on top of Kubernetes, or potentially even more, right? So you always need to make sure that you look after, optimizing wherever it makes sense to optimize. And so when you're developing code, it makes sense to always tune for very specific scenarios. And in Kubernetes, there are very few things that you specifically need to worry about. On VMs, you may be at leisure that you have a much bigger memory space and so forth and so on. But on the Kubernetes side of thing, I would say, there's a significant amount of knobs that are potentially of no interest to you whatsoever.
Well, and to add to specific Kubernetes performance management things you have to be concerned about. You don't want to oversubscribe the node, right? I want to put a workload on there and consume the amount of resources on that node in terms of CPU and in terms of memory. In Kubernetes, there's no swap. So in fact, when you install or configure Kubernetes, there's literally no virtual memory. So what that means is your application can't swap at all. So if there's any memory contention on a node, one of the processes will be terminated to protect the underlying node. Right, and so SQL Server, what's its favorite thing ever, right, is to use all of the memory. And so when you're building and designing clusters, you need to make sure that you have a sufficient amount of memory for the workload that you need. You have to have a sufficient amount of number of nodes to support that workload, such that if a node dies, you still have enough capacity to run your workload. And if there's any swapping that occurs, you need to take that into account.
This is where deploying in the cloud comes into absolute fruition. You're like, oh, I don't have enough memory. Deploy new nodes,
right,
add a new version. New, what's the word?
And I know a guy who's dressed as Luigi on stage that has a really great blog post on that stuff. So you may want to check out his blog.
It's molto bene.
But you can redeploy your nodes with more memory, more CPU, so you're not going to get that issue. Because that out of memory exception thing is a real.
Yeah. So the number one thing that you're going to want to do to protect against that is you're going to deploy with what are called limits and requests. And so limits put upper boundary on the amount of memory a container or a pod can use, and a request is a guarantee. If I need a SQL Server to have 30 or 64 gigs of RAM, and I can put that in the code for the deployment, it's going to find a node that has 64 gigs of RAM and put it there. And so you want to make sure you always use limits and requests when deploying SQL Server.
So can I rephrase that a bit? Basically, when I'm deploying SQL Server, let's just stick with SQL. I mean, same applies to many other stateful database applications, but I mean, this is SQL bit, so I think sticking with SQL Server.
SQL Server is kind of our thing. Yeah.
That's kind of your jam, SQL Server? I did get that.
It's in my Twitter profile.
Marginally important.
Okay, now you're trying to break my flow. So basically saying, you have to take care of potentially different things when configuring it, but similar to when deploying SQL Server on Windows, if you're using a poor configuration, whatever that may be, like, hey, all my log files and all my data files and all my backup files, they all sit in C data, because that's best practice. That's what I've learned.
If you if you have an incorrect configuration, no matter where you deploy it for SQL Server, you're gonna have a bad time.
Okay, so different things to consider, but basically still, if you're doing the right thing, which might just be different considerations, there's basically little to no risk running SQL Server in Kubernetes. Is that a fair statement?
As long as you don't put TempDB on the USB drive, you should be fine.
But my USB drive is USB 3, so it's super fast.
You said little to no risk on Kubernetes.
It's always the people. It's always the people, right?
Any questions online? We're good? Okay, cool.
Okay. You're going to like this one. This panel will now be extended by another 2 hours. I apologize for that.
Oh boy, here we go.
Where's the beer?
The disaster recovery.
Which finishes with us fighting outside.
Sure.
So, running Kubernetes in a data center without considering stuff like always-on availability groups, which is obviously a way to make SQL Server just pure Kubernetes. What's the approach for something like SQL Server from a disaster recovery point of view? How would I set that up?
I have feelings.
You go for it.
Okay.
Yeah, I have multiple feelings, but mainly about you in that.
It's green. It's not orange. He's orange, right?
Yeah, you go for it. Go for it, man.
So
go for it.
I'm going to cover this from two angles. Most often, if you're deploying stateless applications inside of Kubernetes, The easiest way to have a DR scenario for that type of application is to have 2 clusters and 2 regions and use something like Azure Traffic Manager or some sort of global load balancing mechanism that can switch between cluster A and cluster B in the event that there's a failure in that primary zone. Right, that's for stateless applications. And Microsoft has great reference architectures for this within the AKS documentation and talks about how to do all of that using Microsoft technologies, and I'm sure all of the other cloud providers have similar architectural documents. From a SQL Server standpoint, it's the same thing. How do I get access to the SQL Server, and how do I get the data between here and between there? And that same document will tell you use application-specific technologies. So things like log shipping and availability
I was going to say, I
groups.
was about to go, if you didn't mention log shipping. Yeah.
And so however you're DRing SQL Server today is probably how you're going to be DRing SQL Server inside of Kubernetes tomorrow, specifically log shipping. Clusterless AGs are supported, so you could replicate clusterless AG to another region if you want to, but you don't get automated failover for AGs within straight Kubernetes. You have to get the Azure Arc to do that, and that's a whole nother show, right? Arc-enabled data services.
It's
Sorry,
the best.
I have to be very specific, Bent here. So, but that's my spiel. You guys,
And
y'all wanna
by
add
the way,
some?
don't think that because you're running on Kubernetes and you can have this wonderful multi-cloud strategy that you still don't have to take backups and all that stuff. Like, please.
I just
But do
It
we need
is-
to take
it-
backups if I have volume snapshots? That's
No,
the same
literally,
thing,
as I
right?
said before, it's just another platform to deploy SQL Server to. You still need to be taking your backups. If you're going to be using, if you want to go DR, keep it simple and just
Yes.
use something like log shipping. You hear there are a whole bunch of things out there that can say, oh, we could snap this and throw it there and spin it up here. Keep it simple because it's you can dive down a real rabbit hole with some of this stuff, and you want to keep it as simple as possible because if you're all experienced data folks out there, when do things go wrong? They don't go wrong at 4 o'clock on a Tuesday afternoon. They go wrong at 3 o'clock on a Sunday morning. So you don't want to be wading through all these complicated processes. You want something nice and simple to bring things back up.
One of the best investments that a company can make, in my opinion, when it comes to DR is having somebody play the role of an attacker or red team kind of approach and try to force you into a DR scenario.
Oh, we're talking about chaos engineering. Yeah.
yes.
Exactly.
Is that your session tomorrow?
That's my session tomorrow.
Okay.
Yeah.
What a coincidence. So you're saying you're going to have a session about that sometime?
No, we're going to be. It's not technically about chaos engineering. It's Space Invaders on Kubernetes tomorrow. It's a lightning talk.
Yeah, super fun. Definitely go see it. Well, yeah, to add to that, I just did a session before this with Matt Gordon on HADR solutions for the cloud. And there were 4 primary bullet points that we had. The first, and I'm just going to cover 2 because it's going to emphasize what these folks just said. Literally number 1, even for cloud HADR strategies, with backups. And number 4 on that list was build supportable solutions that are easy to maintain.
And that's hard, by the way. That's way harder than it sounds.
It's easy. It was a bullet point on my slide. And it had a
no,
link
it's
to it,
not.
like a thing.
So, would it be a fair statement, is the question, to still assume that main purpose of Kubernetes is still microservices?
I think the usage is expanded, but obviously the foundation is definitely microservices.
Yeah, I'd say foundation is it's evolving release by release, core by the features that are coming in now.
When you start building things on top of Kubernetes, though, you really start realizing that it's so much more than that. Like, for example, if you look at, Kubernetes native orchestrators, workflow engines like Argo, those are things that provide massive value and really have little to do with the fact that they're, that you can kick off microservices off of them, right? You can kick off bots, and you can do a whole bunch of things. But the value that Kubernetes provides is that, it's software, and so as such, you can build a whole bunch of things, a lot of abstraction levels, even on top of Kubernetes itself. So it becomes a really interesting way of approaching infrastructure as code.
There are no stupid questions. Trust me.
So difference between why would I run SQL Server on Kubernetes? So run my own SQL Server rather than run Azure SQL DB, Azure SQL MI, Azure SQL whatever
So my take on it is you may be under contractual obligations, for example, to not run in the cloud or run under your own management, and you assume management on the infrastructure. That is a typical case where you may have like geographical limitations of what you can actually move the data to and from. Right, so there's a ton of scenarios where it makes sense to you actually run SQL Server and Kubernetes yourself as opposed to in PaaS, right?
A really good scenario was put to me, and I'm seriously considering about implementing. Is there's applications that always require an instance of SQL Express running in the background. Shove them into Kubernetes. I don't need a VM to run SQL Express. So shove them in there. They have high availability built in. Let them go. If they fail over, we can build out some storage for them. No worries at all. They're usually like the corporate environment stuff. So if it goes down for like 5 minutes, it's not the end of the world. But shove those into Kubernetes and see how they run instead of just building VMs for them and deploying there.
Yeah.
Ben, you're going to have to help me out here. My hearing, I can't. So what you're saying is you run the compute in Kubernetes and it accesses data wherever the data is. Yeah, this is what we were talking about before, where containers themselves separate out the compute from the data, where we look after our VMs, we stroke our VMs, we look after them. But with containers, we don't care what's accessing our data. We can, I don't like this container, blow it away, spin up a new one, my data's still being accessed. And as Anthony said, it's not about whether SQL Server's online, it's whether we can access the data. Yeah, so absolutely. So Kubernetes, I'd say, would you agree? It's all about the compute,
and you can still do
and then the data is separate.
You can do a very secure implementation of your database and your infrastructure on top of Kubernetes, by the way, because it's designed to be secure from the ground up. So, which is a major concern. Like, we're talking freely about this. Any container can access the data. Like, you can lock it down. All right. Let's just be very clear on that.
And by the way, there's also another session tomorrow that focuses a little more on the how when it comes to deploying SQL Server on containers and Kubernetes.
Really? Who's doing that?
Who's doing that?
BW.
Ah, that guy that's a big deal?
The real BW.
I got you.
The real BW.
The real big deal then.
Bob Ward?
Not Bob Ward.
Buck Woody?
The other BW.
Buck Woody?
Yes.
Oh, okay.
So-
Oh boy, so the question is...
No, absolutely, no.
Do we
I will
want...
take that one because I think I should get an easy question. So
Yes,
it
please.
shows
Because
go ahead.
licensing is an easy question.
SQL Server license, as long as you're talking about SQL Server, I mean, there's the other new offerings like Azure Argenis, that's a different story. But talking about SQL Server, they basically underlie the same constraints. You will have the same editions. You will have standard and enterprise edition. You will still pay for cores. Some things are due to the way that cores and everything are actually exposed to a container or to a pod. Slightly different to consider, but basically speaking, same. It does not matter if you deploy your SQL Server on Linux, if you deploy it on Windows, if you deploy it on containers, or if you just run the MSI.
So yeah, unfortunately, it's not going to make it any cheaper. It's about the same.
Yeah. In the licensing document, it's basically the same as VMs. And I read the licensing document once, and then I took a nap. Right.
I worked at a company
You're
that had
still
a whole
running into the
department
same
explaining
issue, by the
licensing
way,
for
that
us.
if
So
you
yeah.
have a gazillion cores and you only need like one, you're still paying for a gazillion cores.
Yeah, like enterprise licensing for VMware, like that concept of like I can just license the whole host. That concept persists too inside of containers, and so that's may be an effective way to license a larger cluster.
Yes, totally.
So
Anti-affinity and all that stuff, you still will have to consider that for a Kubernetes cluster as well.
we have about 5 minutes left, so I would kind of like to circle back to make sure that we answer the initial question of why we are here. Why are we here? Who are we?
You DM'd me. and
I
said-
DM'd,
Yeah.
exactly.
Actually,
we are here because
same.
I DM'd all of you.
It worked
You
out
are
well.
here because I DM'd all of them, but also because I asked them the question, why do you think, like, maybe in a sentence or so, or two, why should people coming from the data platform, why should they invest, or why should they convince their bosses, or whatever the decision-making process is, why do you think Kubernetes is something that is not just like a little sideshow for, hey, if you're running this specific microservice, or if you need to spin up like a gazillion Nginx instances, that's the way to go. But specifically for data people, why do you think this is something that everyone should at least have like a good may not be everyone becomes a certified Kubernetes admin, but except for Prusky, of course. But then again, he doesn't even have a cool rapper name, so I'm not sure about that.
Why don't you let me go first with that one?
Please.
Here you go.
So my fundamental take on this is Kubernetes is it's a radically different paradigm of deploying applications and data, or managing applications and data. It's where you're relying on the infrastructure that you have deployed as code to do a lot of work for you, in the sense that it can be self-maintaining and self-healing in some situations, right? That paradigm is being embraced by more and more and more customers out there. More and more enterprises are switching away from the old kind of legacy-ish VM model into a Kubernetes and container-based model. And so I think as data professionals, we really need to make sure that we understand that that's the path forward for data in the future. And specifically when we want to think about mobility of data across clouds and across enterprises and across different regions and across different zones. I'll pause there.
Yes, I think it's because it's just another platform we can deploy SQL Server to. So we have, on Windows side, we have the Linux side, we have up in the cloud, we have managed instances, we have SQL DB, we now have containers, and if you want to look at high availability for containers, then you're looking at an orchestrator. The winner of the orchestrator wars was Kubernetes, for good, for bad. Docker Swarm had some good points, bad points, and like all platforms that you can deploy to, you have good points and bad points for it. It can be great for certain things, it can be terrible for other things. Just like managed instance, SQL DB, running SQL Server in VMs in Azure can also be a really bad decision as well. So it's just another option that you have. If you know how to use it, you can take into consideration when you're building out new platforms and new solutions.
For me, let's see. So years ago, I was at a Microsoft event, and I saw Kubernetes for the first time. And what I saw was a bunch of code on the screen that did a bunch of things. It deployed a SQL Server, it attached some storage, it created a load balancer for me to access that SQL Server in like 30 lines of code. And I saw that roll out of SQL Server, and I was like, well, that's pretty special. And then you can take that code, and you can check that in the source control, right? And that defines the state of your application. Because if I have to pick that up and put that somewhere else, well, how do I deploy that? Well, I just take that code and deploy it there, right? If I had to do this 25 years ago, Anthony would have had a checklist and a spreadsheet that I would next, finish, and I might have gotten it right? I might have probably gotten it wrong.
25 years ago.
You hush, young man.
He's old.
But the idea is I have this code artifact that describes the state of my system. And it doesn't just have to be SQL Server. We talked a lot about microservices and building DevOps pipelines and things like that. I could take all of those things and park them in code into a Git repository, and that describes the state of my system over time, and it's source controlled. And that's extremely valuable because the DR scenario to go between clusters then could be, I swipe my credit card, I deploy another AKS cluster, and I pull that code down and deploy. Right? That's amazing capabilities, and that's why I started investing in it years ago when I was at that Microsoft event. I'm like, literally, I was like, this is going to be special. And on the flight home, I was reading books and watching training videos because I was like, this is going to change the way that we deploy applications. But this was probably.
But hold on, it sounds like the credit card is a single point of failure there.
How did you watch these trainings videos? Because you only graded them afterward. I'm confused.
No, I didn't watch my own training videos.
I got it.
But that's what it comes down to. It comes down to speed, getting applications rolled out as fast as possible, and being able to deploy consistently.
I remember first spinning up a container around SQL Server, and it took, what, 10 seconds?
Yeah.
It's amazing. Does anyone remember the days where you had to spin up a whole VM to try and test out a new SQL Server CBT? Because those days are gone. If you want to do that with high availability, you're looking at an orchestrator. Have a look at Kubernetes. Who here is actually using Kubernetes? Has played around with Kubernetes? Show of hands.
Anybody? Your enterprise is using Kubernetes. Raise your hand, please.
Well, not just if you've played around with Kubernetes yourself.
Or management said you have to use Kubernetes.
Is that okay?
Right.
So
I think
there's
that speed and
who here's using? Who here's deployed? Has got Docker Desktop running on their box? Yeah. Cool. There's a little button. If you install Docker Desktop, there's a little button in Docker Desktop you can press that says Create Kubernetes Cluster.
Yep.
And it'll spin it one node up for you. You can get running with it. You can look at my blog. There are Anthony's blog.
His blog, really. Let's be
his blog as well. There are other blogs available.
Exactly. So we've put a couple of
and you can get something running in Kubernetes in 10 minutes. And,
Yeah,
and once
I
it's up,
was trying, but
Okay.
my
it's
favorite
time.
thing is just try and see how you can break it. It's time. Do I need to stop?
It's time. You should stop. Yeah.
when Ben
Okay.
keeps talking over you, there's a reason for that.
I'll
So,
stop when they cut the microphone from me.
Okay. Having that said, we've put up a couple of resources there for you. There's a bunch of Pluralsight content from 3 of us. For those of you that do not have a Pluralsight subscription, come see us. We can make that happen. Anthony also wrote a book, actually 2. And we're going to give 2 of them away in a sec. There's also a very nice GitHub repo up there. And there's also
What is it,
Anthony and Andrew's blog up there. You're going to find all these links as well in the materials to download. And with that, we have 2 books to give away, but I think we should make it...
To make it a little difficult?
I know.
Thank you.
Try the fish.
Try the fish.
It's 6 o'clock on a
maybe we
Friday.
should just
Give the
have,
people
like 2 questions to give them away. Anthony, you got something, like a nice trivia for the
Let's
audience?
see.
Or any of you 3, actually, if you have a nice trivia question.
I have one that's decent.
Go
Do you
for
have-
it.
you
Not
go.
off the top of my head. No. Go on.
Go for it.
So what was the thing that I should configure for every SQL server that I deploy in Kubernetes? There were 2 things that I said. Does anybody remember that? Was that you? That right there. So-
Wow. Fair play.
All right, 1, 2. There we go.
Yep.
1, 2.
Yeah.
Awesome.
So this gentleman in this 3rd row and the gentleman in the last row.
See, we don't even need
Winner,
a second
winner,
question.
chicken
We have
dinner.
2 people answer first. With
Fair
that,
play
thank you
to
very
you.
much.
Fair play to you.
Enjoy the party tonight. Thank you
Yep,
for
thank you
coming.
very much for
Hope
coming.
you-
Cheers.
Thanks, folks. I appreciate you coming.